far is it from here to here? How much does the television set you're watching weigh? And how many years old are you? See, we measure things all the time. That's how we compare one thing to another. Measuring things is how we understand the world. And especially, it's how we understand our place on it. Measuring things allows us to figure out how long it takes to get from one place to another. If we didn't measure things, everything we build would fall right down. The better we measure, the better things fit. Are about this big. So we've always wanted a unit of measurement about this long. And we want it to be the same for everyone. We want it to be a standard. That's why it's hard to use something like a foot, because not everybody has the same size feet. So what we did is we looked at the Earth and we divided the distance from the North Pole to the equator in 10 million times. And we got this. It's a meter. We use tens because humans have 10 fingers. Now you can keep going. You can divide a meter by 10 and 10 again, and you get centimeters. There are 100 centimeters in a meter, just like there are 100 cents in a dollar. You can divide it by 1,000, and you get millimeters by a million, and you get micrometers. It's easy. With a meter, you can measure just about anything. This microphone is about 32 centimeters long.
What?
It's the metric system. It's easy.
What?
I said it's easy.
What? There's so many things in this world to measure. You got weight, length, mass, liquid, speed, temperature.
Yo, how are people supposed to measure all this stuff, man?
You got to unify. You know what I'm saying? You got to unify the system.
Yo, they need to calculate and relate. That's what we talking about. Yo, tell him, Kilometer.
My name is Kilometer and I'm always ready. You can use me to measure the speed of Andretti. In this crew, yo, I'm the biggest one. You can use me to measure this planet from the sun. And when you take a trip, you better come equipped. Use a map without me and your plans will just slip. Telling you, G, Kilometer is me. I'm the biggest one here, daddy of the family.
My name is Mita, and you know I'm real cool. In the metric, I'm the basic unit measuring tool. I am the glue that other measures are from, cause I stick to the end of their names just like gum. And when you see a track with pros running around, when they measure the race, that's where I'll be found. Cause many things in this world are measured by me, and that includes the depth of the sea.
My name is Decimeter. I'm not used a lot. Even on your ruler, I don't have a spot. I'm just like a meter, but divided by 10. I'm a helpful measurement, but you got to know when. If there's too many centimeters, there's no need for alarm. Cause you can use me when you're measuring your foot or your arm. I'm 10 centimeters, and you know that's true. But measure down from the meter in the metric crew.
I'm centimeter, everyone knows me. I'm the one in your mouth that you see mostly. I'm 0.1 decimeter or 10 millimeter. When you're measuring the snow or the rain, there's nothing sweeter. Take a look at your ruler, you can check me out. I'm on the side with millimeter, just in case you should doubt. I'm used by a tailor if the hem of the blouse, and was a tool for the carpenter that built your house.
Now the metric is the way to go. Almost every country in the world is part of the flow. Using metric units is so easy and fun. Put together by the French in 1791. There's many different units that we use today, but the ones that we are show the others the way. Cause you can measure in grams or liters to gallons, seconds, or even gigabytes on your computer for protection. There's also 20 levels of all measurements now, and you can measure them all if you just know how. You see, there's only one rule, use again and again, is that we're all separated by the power of 10.
You may not realize it, but measurement rules your life. It tells you what kind of clothes you need to buy, and how far you can go on a tank of gas. That's a good thing, really. Measuring things has helped us give a kind of order and logic to our vast universe, and to our everyday lives. Take length. The long and the short of it is, we frequently need to know how far it is from one point to another. To buy a pair of shoes that fit, you need to know how long your foot is. To get you to school on time, your parents need to know how far away your school is. We take all this for granted now, but how did we first come up with rulers, miles, feet, and all the rest? In the beginning, man was his own measure. 2 steps made 1 pace. 1,000 paces made a mile. Fingertip to fingertip made a fathom. That's 6 feet. And the distance around the waist of a man was a girth, or 3 feet. But what was a foot? Well, the foot was a foot, like the hand was a hand. The finger was a finger, and a span was the distance from pinky to thumb. But the ruler of rulers was the elbow, or as it was better known by its Latin name, the cubit, the distance between elbow and fingertip. The ancient Egyptians used cubit rulers to achieve amazing precision in their architecture. The sides of the Great Pyramid of Giza are more than 750 feet long, and they're only off by this much. You don't hear much about cubits anymore, but the fabulous foot still has legs. It has ambled around different civilizations for thousands of years, and of course it's still used in the U.S. customary system. In ancient Rome, the
the foot was both a unit of length and weight. It was the length of a special copper bar which had been fashioned to weigh exactly 1 pound. The bar was divided into 12 equal parts called unciae. As a unit of both weight and length, it was the source of the modern terms ounce and inch. Unfortunately, from country to country, the average length of the male foot varies. This sort of measurement mayhem eventually caused big problems for the very first traders. As units of length varied from place to place, no one knew how much of anything they were buying. A yard of fabric in France might be different from a yard of fabric in India. Traders decided they needed an absolute standard. Henry I, a king of England in the 12th century AD, decreed that the standard yard was to be the distance from his nose to his fingertips, a little less than 3 feet. He commanded that an iron bar be forged to this length. In the 16th century, Britain's Queen Elizabeth wanted to put her own stamp on Henry's yard. Adding her initial E made the official yardstick almost exactly 36 inches long. But in 1834, a mighty fire ravaged England's Houses of Parliament. One of the most precious pieces of metal in the land, the standard yard, was lost. Scientists saw their chance. They could do away with a system based on the length of some monarch's limb, which of course varies from monarch to monarch. They wanted their new yard to be based on the laws of science, so that it could always be accurately reproduced. So, where did they look? To a pendulum. Back in 1581, the 17-year-old Italian scientist Galileo was fascinated by a candelabra he saw swinging in Pisa Cathedral. He timed the candelabra's swings with his pulse, and observed that the time it took to travel from one end of its swing to the other was always the same. He went on to prove that it made no difference whether the swing was big or small. What determined how long the swing lasted was the length of the pendulum. Galileo's 200-year-old observations provided the principle scientists wanted to take advantage of. Their yard was to be the length of a pendulum that would generate a swing of exactly 1 second in duration. On paper, the theory was sound, but in practice they couldn't make it work. The fluctuating effects of gravity upset their designs. The British had failed in their attempts to create an absolute standard of length. The French were more successful, thanks to the French Revolution of 1789. It was a revolt against bad rulers, to be sure, but not the kind you measure with. Still, a new way of thinking about measurement emerged. It was called the metric system. The metric system took as its starting point a new unit of length. Scientists proposed that this new unit, the meter, be derived not from the human body, but from an established scientific constant, the circumference of the Earth. 1/10,000,000th of the distance between the North Pole and the equator was to be 1 meter. A survey of this distance ended up taking 10 grueling years. Mathematicians used the survey results to calculate the distance from the pole to the equator. A bar, precisely 1/10,000,000th of this distance, was then constructed from platinum. Stand aside, cubit, yard, and chain. Be off, inch and foot. Make way for the meter. Unfortunately, explorers later discovered that the Earth was not a regular shape. Once again, we were a long way off from a standard unit of length. Now, at last, scientists have finally gotten it right. And it took until the end of the 20th century to get there. Length is now based on, are you ready for this? Speed. The speed of light, that is. It's a bit quick, but at least it's constant. The meter is now the distance traveled by a beam of light in a tiny fraction of a second. To be precise, about 3/billionths of a second. That's not a very long time, but trust us, it's a distance you can count on.